All right. I had changed this to alternating interior angles to alternating exterior angles. Then I realized I made a mistake. Oops, my bad. So what we're doing here is there are actually two sets. So up here, I gave you one of the sets, angle 5 and angle 3. I didn't write it up here, but you need to write it in the space that's here. For this second one, copy down the same definition and then give me the second pair of alternating interior angles. We're going to pause this video. You're going to take advantage of rewriting the definition and then putting the second set of alternate interior angles. The teacher is going to walk around and check to make sure that you've done it. I don't trust y'all. I want to make sure that you're taking the notes and that you have the notes. So on your paper, you need to do this. The teacher will walk around, pause the video, and check to make sure that you got the second pair of alternate interior angles. I think it's kind of obvious, but there's really only one set left inside the two parallel lines and alternating across the transversal. I am going to move up. So our next one is corresponding angles. Corresponding angles. To me, that's kind of probably one of the hardest words that we're dealing with this, but corresponding angles. I'm going to have the teacher pause the video. You guys think of what do you think is corresponding angles? What do you think is corresponding angles? All right, when we're dealing with parallel lines cut by a transversal, the corresponding angles are the angles that are in the same location, but on a different parallel line. So angles, and wow, I typed that fast, didn't I? Haha. The beauty of video recording. So angles that are in the same location but on different parallel lines. So I'm going to say, for example, that I'm looking at angle 1. So what other angle is in the same location as angle 1 but on a different parallel line? So angle or line M is a parallel. Line M is parallel to line N. P is our transversal. So what angle is in the same location as angle 1 but on a different parallel line? Same location. So angle 1 is here. If we go to the same location on angle N, we have angle P. So in this space or over here, I want you to list all the angles that are corresponding angles. All the angles that are corresponding angles. All right, the teacher's going to pause the video so that you guys can list all those angles. Just remember they had same location on the line. All right, let's go to consecutive same side interior angles. To me, this tells you the definition. So I want you guys to think about what it's saying. Consecutive same side interior angles. Consecutive same side interior angles. Teacher's going to pause the video so that you guys could tell what you think is consecutive interior angles. Same side. Good job. So angles that are consecutive same side interior angles, those are angles that are inside the parallel line and are on the same side of the transversal. Angles that are inside the parallel line and are on the same side of the transversal. So if we're looking at this, the angles have to be inside of the parallel line and on the same side of the transversal. So when I look at this, I'm looking and I see what angles are inside the parallel line and on this side of the transversal. So I see angle 4 and angle 5. So angle 4 and angle 5 are consecutive same side interior angles. Ooh. So in this space, you're going to write angle 4 and angle 5 consecutive interior angles, and then you're going to give me the other two angles that are same side interior angles. So we already said angle 4 and angle 5. What other angles are same side interior angles? All right, the teacher's going to pause the video so that you guys can write those down. All right, now we're going to go to consecutive same side exterior angle. Consecutive same side exterior angles, just like it sounds. So if you have an understanding of what consecutive same side interior angles are, then you should have a understanding of consecutive same side exterior angles. So we're going to pause the video. Teacher, please check to make sure that the students are writing down what they're supposed to write down. Some of the times they take a break and they don't write down what they're supposed to write down. So please check to make sure they're writing down what they're supposed to write down. All right, so consecutive same side exterior angles are angles that are outside of the parallel line but are on the same side as transversal. Very similar to consecutive same side interior angles, angles that are inside the parallel line and on the same side of the transversal. Consecutive exterior angles are angles that are on the same side but also on I messed that up. Angles that are outside the parallel line but are also on the same side as transversal. So I'm going to go with number 1. If I'm looking here at number 1, it's outside of the parallel lines and it's on the left side of the transversal. So what other angle is outside of the parallel line and on the left side of the transversal? Well, that would be angle 8. Angle 8 is outside of the parallel line and it's on the left side of the transversal. So over here you would write angle 1 and angle 8, and then you would tell me the other set of consecutive same side exterior angles. All right, teacher, please make sure that the students are filling in this information. All right, he is gonna pause the video and walk around and check and make sure. We should already know what supplementary angles are because we've actually done quite a bit of supplementary angles. So what I want you to do is I want you to tell me and over here what is supplementary angles. Teacher's gonna pause the video so you guys can tell me what are supplementary angles. All right, so supplementary angles are two or more angles whose sum is 180 degrees. So that's supplementary angles. So when we're looking, what two angles can we say is 180 degrees? We also call supplementary angles what type of angles? So pause, see if you could think of what we also call supplementary angles. So supplementary angles are also called straight angles because when you put them together, they make a straight line, and that straight line is also called a straight angle. So what I want you to do is I want you to look over here and see what angles are supplementary to each other. What angles make a straight line? So if I'm looking at angle 1 and I'm looking and say, okay, angle 1 comes here and goes here. This is line P. So angle 1 and angle 4 make up line P. So those two angles are supplementary to each other. All right, I want you to list all the angles that you think are supplementary to each other. I'm going to pause the video so that you guys can list all the angles that are supplementary to each other. All right, next we're going to look at linear pair and adjacent pairs. With linear pairs, to me, these have the same definition. Most of the time when you think about linear, you think about making a straight line. So you're looking for two angles that will make a straight line or are supplementary to each other. So linear pair are two angles that are supplementary to each other. So in other words, their sum add up to be 180 degrees. Their sum add up to be 180 degrees. So I want you to list some supplementary angles. All right, the teacher's going to pause the video, walk around, and make sure that you guys are doing this. All right, let's look at adjacent angles. A lot of the times people will say that linear angles and adjacent angles have the same definition. To me, there's a difference. You can have a linear pair and not share a ray or part of the angle. Adjacent angles have to share an array. Adjacent angles are two angles that share a ray. So one part of one angle helps to make up the other part of the other angle. So when I look over here and I'm looking what two are adjacent angles. Well, angle one shares a part of its angle with angle 2. Angle 1 also shares a part of its angle with angle 4. So those are adjacent angles. They're right next to each other, and the makeup of those angles are used together to make up the other angle, the pair that they share. I need to go back up here because I honestly think that there's a mistake made on this worksheet, and I want the students to change this from alternate interior angles to alternate exterior angles. And the definition for alternate exterior angles is similar to that of alternate interior angles. It says are the angles when a set of parallel lines are cut by a transversal. The angles alternate across the transversal but are inside the parallel line. They're still going to alternate across the transversal, except this time they're going to be on the outside of the parallel line. So these are angles that, and I know some kids are in there being huffy and puffy about it. Yes, I made a mistake. Oops, my bad. Please forgive me. But I realized some reason I thought that we would come back to alternate exterior angles, and we didn't. So I need for us to make sure that we know what alternate exterior angle is. So it is our angles that are alternate across the transversal but are outside the parallel line. So if I start here with angle 1, I want an angle that is outside of the transversal. Alternate across the transversal. So 1 is on the left side. I'm looking for an angle that is on the right side, but it's also on opposite sides of a parallel line, outsides of the parallel line. So alternate across, so I got angle 1. And if I alternate across, I'm going to come all the way down to angle 7. Angle 1 and angle 2 are adjacent, so they're not alternating exterior angles. So I got to go all the way on the other side of the parallel lines, outside of the parallel lines. All right, so at the bottom of your paper, it says a comparison of congruent versus similar. They're telling you that these two triangles here are congruent triangles. What I want you to do is I want you to list what you notice about these two congruent triangles. Down here, we have similar triangles. I want you to list what you notice about the two similar triangles. Then I want you to tell me what's the difference in between the congruent triangles and the similar triangles. How are they the same? How are they different? All right, the teacher, actually, we're going to end this video here because I'm about to run out of time. So write this. The teacher will walk around to make sure that you're doing it. All right, thank you very much.